General overview. Betelgeuse, a red supergiant star in the Orion constellation, much larger and more massive than the Sun. It's one of the largest stars visible to the naked eye and is about 650 light-years away from Earth. 2. Behavior and observations. Recent changes. Betelgeuse has exhibited unusual behavior recently, including a significant dimming and an increase in brightness, which has sparked various speculations among astronomers. Possible supernova. Some scientists believe these changes might indicate that Betelgeuse is nearing the end of its life, potentially leading to a supernova explosion. However, it's also possible that these fluctuations are due to other factors, like dust clouds or sunspot-like activity on the star's surface. 3. Significance. Supernova potential. If Betelgeuse were to explode as a supernova, it would be a spectacular event visible from Earth, but not harmful to life here. Astronomical impact. The explosion would contribute to the enrichment of the interstellar medium with heavy elements, which are essential for the formation of new stars and planetary systems. 4. Cultural and historical importance. Historical observations. Betelgeuse has been noted throughout history by various civilizations, recognized for its brightness and distinctive reddish color. 5. Future research. Ongoing studies. Astronomers continue to monitor Betelgeuse closely, using advanced telescopes and models to better understand its current state and predict its future behavior. Betelgeuse remains a fascinating subject for astronomers, offering insights into the life cycles of massive stars and the dynamics of stellar evolution. In the star-gathering Orion, there is a star that has hypnotized cosmologists for a seriously significant time frame: Betelgeuse. This red supergiant star is much greater and more massive than our Sun. In recent years, Betelgeuse has been acting curiously. It has dimmed significantly and has even started to vibrate fiercely. This has provoked speculations that this once energetic star is approaching an infinite blast. Yet, consider the possibility that we are truly seeing the beginning of a more subtle and disturbing event. Consider the probability that Betelgeuse isn't going to explode but instead collapse on itself. Join us as we explore the most recent research on Betelgeuse and its potential implications for our planet. Through this investigation, we plan to comprehend the critical impact Betelgeuse's collapse could have on the future of the universe. The secrets of Betelgeuse. Betelgeuse is a huge star, multiple times larger than our Sun, and is among the universe's biggest. However, its size comes at a cost. Stars like this have limited lifespans, and Betelgeuse is no exception. It's a ticking time bomb, ready to explode, yet the exact moment remains a mystery. Situated around 650 light-years away, Betelgeuse has charmed astronomers, shining as one of our closest stars. We marvel at its brilliance, attempting to unravel the secrets hidden within its fiery depths. However, only 13.3% of its brilliant energy is visible to us. If we could see its full glory, it would outshine even Sirius in the night sky. The galactic life cycle. Imagine a titanic star with a radius many times that of our Sun, extending beyond the asteroid belt and nearly touching Jupiter. Within this massive area, Earth, Mars, Mercury, and Venus would be immersed by Betelgeuse's huge gravitational force. But the surprises don't end there. Like clockwork, Betelgeuse sheds a solar mass, pushing off its outer layers in a brilliant display of cosmic majesty. A cloud, many times larger than the star itself, envelopes Betelgeuse, covering it in an ethereal fog that captures our gaze. This cloud, expanding 30 light-years, invites us into a grand cosmic dance, urging us to uncover its secrets. The core of a star. We must delve deeper into the core of Betelgeuse's creation, where the nuclear fusion of hydrogen creates helium in a massive explosion. Over time, the star's hydrogen fuel diminishes, leading to a stellar transformation. As helium fuses with carbon, it releases brilliance that courses through the universe. However, even this glorious fusion has its limits. As neon merges with iron, an incredible change occurs. The star's gravity, now unchecked by energy output, triggers an impending collapse, pushing Betelgeuse toward a fate both awe-inspiring and horrific. A supernova blast. The fate of Betelgeuse. Stars undergo a fascinating transformation, evolving from the energetic blues of youth to the fiery reds of maturity. During the 2nd century BC, Chinese astronomers observed a stunning celestial phenomenon. Betelgeuse's distinctive yellow hue set it apart from the cosmic tapestry. As the centuries unfolded, the baton of observation passed to Greek and Roman astronomers, such as Ptolemy in the 2nd century AD. In his meticulous records, he described Betelgeuse as having an orangish or tawny appearance, a characteristic that still captivates us today. This persistent shade, across various cultures including medieval observers in the Middle East, adds to the intrigue surrounding Betelgeuse. Another twist. The story of Betelgeuse takes another turn as we dive deeper into its unpredictable behavior. In 2019, the star bewildered experts by suddenly dimming. Scientists initially thought that a massive dust storm expelled from the star's surface blocked our view. However, the origin of the cloud remains unclear. Some researchers speculate that a massive object, like a planet, might have disrupted the star's surface or even been swallowed by it. Recently, Betelgeuse has become nearly twice as bright as its usual brilliance. This is surprising because stars typically dim as they age. Scientists are unsure about the cause of this sudden increase in brightness, but they know that stellar brilliance can fluctuate for various reasons. For instance, some stars undergo cycles of bright and dim phases. Betelgeuse is known as a variable star because it changes in brightness, expanding and contracting regularly, which alters the amount of light it emits. This is a common occurrence with many stars, including Aldebaran and around 30 other stars visible in the night sky without a telescope. Supernova shone inside Betelgeuse's core. A seismic shift was occurring inside Betelgeuse's core, with the release of fiery material into space, creating a massive dust cloud of significant proportions. This dust veil obscured a large part of Betelgeuse's brilliant light, transforming it from a dazzling beacon to a subdued light in the night sky. Betelgeuse's brightness dropped to previously unimaginable levels. Once considered among the top 10 brightest stars, it now ranks lower than the 20th brightest. In recent months, Betelgeuse has baffled astronomers, challenging the norms of stellar behavior. Researchers and cosmologists worldwide have been fascinated by this intriguing celestial dance. Theories abound, attempting to unravel the mystery of Betelgeuse's strange behavior. Some speculate that massive sunspots or dust clouds are responsible for its dramatic fluctuations, while others consider the possibility of cyclical patterns. Their research has uncovered the startling idea that Betelgeuse's supernova blast may have already occurred. Yes, you heard that right. While previous estimates projected its supernova event to be millennia away, evidence now suggests a different story. The supernova's implications. The last observed supernova in our galaxy, the Kepler supernova, graced the sky centuries ago. Researchers have proposed a model suggesting that Betelgeuse is in the late stage of carbon burning, indicating it may be on the verge of a stellar explosion. This positions it as a strong candidate for the next anticipated supernova event in our Milky Way galaxy. Like a grand finale in a cosmic symphony, Betelgeuse stands as a prominent contender for the next stellar supernova in our beloved Milky Way system. However, studying Betelgeuse is like solving a puzzle with conflicting observations. There are signs of material ejections and subsequent recovery, leaning towards a mass ejection event, yet smaller in scale compared to our Sun. Observational challenges and supernova visibility. The challenge lies in the current difficulty of observing Betelgeuse. Scientists have been studying Betelgeuse for years and have found that its brightness has changed over time. This suggests that the star is aging and could go supernova soon. However, there isn't enough evidence to predict exactly when this will happen. A supernova is an extraordinarily bright explosion that occurs when a star dies. It isn't harmful to life on Earth and is safe to observe from our planet with the naked eye. Understanding Betelgeuse's role in cosmic evolution. Betelgeuse, a red supergiant in the Orion constellation, plays an essential role in the life cycle of stars within our galaxy. Its evolution offers a window into the future of other massive stars, providing crucial clues about the end stages of stellar life and the impact of supernovae on the cosmic environment. To understand Betelgeuse's significance, we need to delve deeper into its stellar structure, life cycle, and the broader implications of its potential explosion. Stellar evolution and supergiant characteristics. Betelgeuse, classified as a red supergiant, is a product of the late stages of stellar evolution. Unlike smaller stars, which burn their hydrogen fuel more slowly and enter a red giant stage, massive stars like Betelgeuse consume their nuclear fuel at an accelerated rate. This rapid consumption leads to the expansion of the star's outer layers and the formation of a supergiant. The core of Betelgeuse primarily consists of helium and heavier elements like carbon and oxygen. As the hydrogen in the core is depleted, fusion reactions begin to occur in the outer layers, leading to the star's expansion. This process is governed by the complex interplay of gravitational forces and radiation pressure, which eventually results in the star reaching its supergiant stage. The core fusion process. At the heart of Betelgeuse, nuclear fusion continues to drive its radiance and size. Initially, hydrogen fuses into helium in a series of reactions that release vast amounts of energy. As hydrogen is exhausted, the core contracts under gravity, increasing temperature and pressure. This allows helium to fuse into heavier elements like carbon and oxygen. The star's outer layers expand significantly during this stage, resulting in its enormous size and distinct red color. In supergiants like Betelgeuse, this process is more complex due to the star's high mass. The core undergoes several stages of fusion, creating a series of concentric shells where different elements are fused. Each stage of fusion alters the core's composition and energy output, leading to the star's dynamic behavior and eventual instability. The supernova mechanism. When Betelgeuse depletes its nuclear fuel, it will no longer have the energy to counteract the gravitational pull of its own mass. This leads to a dramatic core collapse, triggering a supernova explosion. The supernova mechanism involves a series of rapid events. Core collapse. Without sufficient pressure from fusion reactions, the core collapses under its own gravity. This collapse occurs at an astounding rate, compressing the core into a neutron star or black hole, depending on its mass. Shockwave formation. The collapse generates an